Regarding the composite restorations, in the presence of an initiator, as we have mentioned in the video of the composite restoration, an initiator that is activated by light, like the camphoroquinone, or an initiator that is activated by itself by a chemical reaction, like the peroxide initiator, the monomers or oligomers of the resin polymer will be converted into polymers or monomers. And because the conversion of these scattered monomers or oligomers into an arranged polymers will make them smaller, that will lead to an expression called as a polymerization shrinkage. Polymerization shrinkage is a shrinkage that results after the hardening or the polymerization of a resin. And because of that, in composite restorations, we will try to always avoid this polymerization shrinkage by avoiding the composite from contacting so many walls, so that because the more resin in a composite, the more that the composite will shrink, so that we should always try to avoid the composite from attaching the tooth walls and making as less as possible. Let's make 2 to 3 walls as average, and the others are just increments. That will lead to the configuration factor, or simply the C factor. The C factor is resulted from the division of the bonded to the unbonded tooth surface, and so that as we can see here in the right, the class 1 and the class 5 cavities have 5 bonded surfaces and 1 unbonded surface, so that the C factor will be very big, which is 5. In the middle we have the class 2 and the 3 restorations having 4 bonded surfaces and 2 unbonded surfaces, resulting in a number 2 C factor, which is also big. But the least C factor that is present in the class 4 cavities. Class 4 cavities have 2 bonded surfaces and 4 unbonded surfaces, so that there will be the least tooth contact and the least polymerization shrinkage and the least configuration factor or C factor, which is a half. So that the C factor is the ratio of bound to unbound surfaces in an uncured composite. A higher C factor means that the composite material is touching more walls. When composite is bonded to more walls, higher internal stresses, BAD, is produced than if the composite was bonded to fewer surfaces. So in order to create a great composite, place many small increments and only bond to 2 or 3 walls at a time.